Welcome back, my friends. Here we are in video 2 on exponential functions. In this video, I'm going to tell you a little bit about exponential growth, and then we're going to do this example that you see right at the top of the page. So first, I want to set you up with a few basics about exponential growth. So this is what an exponential growth function will look like. Let's say I have this function, f of x is equal to ab to the x power. And A here represents your starting population. So A is called usually the initial value. And you can think of this as the starting size. I'm going to say AKA the starting size of your population. B, this value of B here, is the base of our exponential function. B is the base. But it's also the growth factor. The growth factor. It's what rate this is increasing at. It's called the growth factor, sometimes also called the growth multiplier. And it's how much faster, it's how much your function is growing at. And then x is your variable. It's usually time. It's usually time. So let's take a look at this little example here. So this is from your Lumen interactive exercise. It says the population of China was about 1.39 billion in the year 2013, has an annual growth rate of about 0.6%. So this is the growth function we're looking at, where t is the number of years since 2013. And so let's go through here a little bit what they're working with. So here you can see our b is 1.006. That's our b value. And that's coming from the percentage here. We have also this A value is 1.39. That's our initial starting population. And we're getting that from this 1.39. So we're starting in the year 2013. So our initial population is 1.39 billion. And then it grows each year by about 0.6%. And so what we've done to get from 0.6% to 1.006 is we've written that 0.6% as a decimal value, and then we've added to that the number 1. So let me show you that, where we're getting that in the text, in the problem. So let's kind of go through what we have here so far. A is the initial value of 1.39 billion people in the year 2013. B is equal to the growth rate, and so the growth rate, so we have 0.6 or 0.06, excuse me, 0.6%. Oh, I'm sorry, I was right the first time. 0.6%. And to write that as a decimal, we're converting that into 0.006. Then what we're doing is we're saying, look, every year you grow by 0.006%. The 1 that we're adding here is capturing all of the people who were already alive. So the 0.006 is the growth. We're taking a 0.006 of a population. That's how many new people we get. And the 1 is sort of representing all the people we had before. So that's where they're getting this 1.006 factor for B. And then T, the value they give us for T, is years since 2013. So don't get tricked here. If I tell you T is equal to 2, that means 2 years since 2013. which what year is that? That would be the year 2015. So that's what we have here. And then the problem is asking us to find the population size in 2031. So we want to find out in 2031, what is the population size? And we can do that. We can do that. So the first thing to do is we want to think about 2031, and we want to think about how many years between 2013 and 2031. So we should set our t, sorry, that was an ugly t there. Our t should be equal to 2031 minus 2013, because that's going to tell us how many years there were in between those two dates. And that's going to give us 18. So now we know this is the value we need to plug into our function to find the population in 2031. So let's go ahead and do that. Let's go ahead and say P of 18, and that's going to be equal to 1.39 times 1.39 times 1.006 to the 18th power. And you should feel free to evaluate this in your calculator, my friends, okay? And what you'll get is that this is approximately 1.548. And remember, this is in billions. So this is approximately 1.5 billion people will be the population at that time. This is a little quick introduction to exponential growth. I think exponential growth is on all of our minds right now because one thing that experiences exponential growth is viruses. Viruses experience exponential growth. And I found a really good video for you guys. Viruses experience exponential growth. I found a really nice video for you guys that's going to explain a little bit about how COVID-19 works on an exponential value. So I'm going to put that video next. What I want you to do is take really good notes and pay attention. So some of the material in that video will help your understanding, and some of it will be a little bit over your head, and that's okay. So just get as much of it as you can. We will talk about it in class. I'm not holding you responsible for all of the problem solving in that video. I just want you to watch it because I think it's really well done, and I think it'll give you a good perspective on how COVID-19 is working mathematically with some of this material that we're learning. So take a watch of that, see what you think about it. This is really more of a brain teaser in the next video. You don't have to worry about understanding every little detail. I just want you to get thinking about exponential growth and COVID-19. And then in the video right after that, I will be showing you how to find the equation of an exponential function.